There have been many space settlement proposals in the past, but they often focused on singular aspects of the space settlement. With Anaptyxi, we wanted to elaborate on the entire process, from lunar bases to the orbital settlement to mining operations instead of segregating these as a side note. The goal of our proposal was to combine many different ideas of space exploration to form one ultimate project, Anaptyxi. The structure composes of a rotating residential torus, a rotating agriculture and recreational torus, a rotating industrial coaxial cylinder, and a non-rotating industrial cylinder, and so in reverse. At the top of the central hub is a volume allocated for zero-G recreation, and at the bottom are adjustable thrusters. The sky on the tori is an OLED HDR screen, as it would be most comfortable for residents. The down surface of the residential tori have solar panels on them, effectively using the down surface. There are cargo docking ports on the industrial non-rotating cylinder, as industrial activities require heavy import and export of goods, so the process needs to be quick and efficient, and the complexities involving mancraft docking are not a factor. There are also nitinol SmartFlex actuators forming a dynamic radiator strip for thermal rejection on the rotating industrial cylinder's down surface. Mancraft dock at the docking ports located on the central hub. The industrial cylinders have both pressurized and non-pressurized for the various kinds of research which may be needed to be carried out. The agricultural and recreational torus lies in the middle of the residential torus and also provides tourism facilities in an isolated part of the torus. There are individual sections for agriculture, as there is different atmospheric conditions ideal for growth of plants, which would not be easy to adjust to for humans. This torus is also used for recreation due to lowered 0.7 g gravity. As for the materials, we have a multi-shock shield to shield from hypervelocity impacts, a graded Z shield to protect from various kinds of radiation through an ordered array of increasing Z materials, grade 5 titanium as a hull material, alloy as a super light and efficient thermal insulation compound, lunarcrete as a base ground, and polyester foam as a cushionary coating on the floor, with medium density polyethylene as the surface. This application of adhesive elasticil at every layer. There are 5 stages of construction sequence. Before the start of construction, the lunar base and Mars drivers are constructed up to fully operational capacity. Stage 1 takes place from 2041 to 2042 and consists of the launch of the initial central hub into orbit, from where the rest of the settlement will develop. Stage 2 occurs from 2042 to 2045 and consists of the construction of spokes, the antenna, as well as the residential tori starting from the wireframe. Stage 3 occurs from 2045 to 2047, and here the rotating industrial cylinders and recreational cum agricultural tori will be constructed. During stage 4, from 2047 to 2048, the industrial cylinder, docking ports, the zero-G recreational volume will be constructed and the internal infrastructure laid out. In the final stage, the screen-based roofs and the thruster will be constructed. All volumes will be pressurized and fully operational capacity will be reached. As for the scope of future expansion, we can construct a large disk for communicating with missions which may go far away, and can either add a stack of volumes or add another layer in a pre-existing stack. A Mars analog can also be constructed with conditions like gravity and simulated environment similar to Mars. The atmospheric pressure will be 0.8 Earth atmospheres with increased proportion of oxygen, so residents don't feel discomfort. There will be travelators for residents wanting to travel from one area to another, as this way they can get some exercise while being able to reach their destination relatively fast. Transportation of water, laundry, sewage, etc. will be done through a single very wide pipe-based system which connects to every house and the respective facilities for processing of goods on the settlement, which transports goods via conveyor belt except for liquids which are pumped. Now talking about power sources, it is unfeasible to use nuclear power. In the case of fission, the reaction itself is very dangerous, as well as the byproduct, and for fusion, too much energy is needed to maintain the reaction, and therefore too much heat rejection is required. Therefore, solar cells will be the primary source of energy, and the energy will be stored in a lithium-ion, nickel-manganese, cobalt battery, as it is more durable than other types of lithium-ion batteries. The 3PS system can also be used to beam energy from the moon surface through microwaves to the settlement.
The construction will begin with the framework, made using Spider Fab, a flexible construction robot deploying structures in a way reminiscent of a spider spinning a web, which places solar cells using the trusselator. Then, the exterior construction bot will place the hull material. The interior construction bot will lay down the pipelines and the ground of the settlement. The construction of the buildings will be done by the contour crafting bot at a rate of 2 days per building. The command center will monitor all automation and will have control and will also be used to notify residents about emergencies. Server farms will store the biometrics and data of 900 people and will use laser communications. Predictive models harnessing the power of quantum computing and CCTV footage will also flag suspicious behavior for review and disrupt systems in case of emergency. Quantum cryptography, being the safest method of communication, will be used for the critical communications on settlement and with grounded bases. The residents will be given a phone and a smart band for accessibility and productivity. We will have HABs inside the lava tubes of the moon. It will arrive flattened from Earth and will set itself up with a pre-charged battery in place. The basic structure is a geodesic polyhedron, which distributes its stress equally over the surface area. Inside is a construction machinery, the fabrication machine, and the tools for bots. The fact that it lies in a lava tube simplifies the design majorly. There will also be a surface city as a central base. It has various components such as a control center, life support base buildings, mineral processing areas, and storage. The radiators on the exterior will reject the immense heat generated during heavy processing. Heavy-duty transportation will be done through a maglev train on the surface of the moon. The energy for various processes will be acquired through solar arrays to the circumference of the moon and transported through wires. The lunar surface-based construction rover will set up the lunar settlement inside the lava tubes of the moon. It will assemble the glass structure and bricks to construct the lunar city. The bricks and glass will be placed by the bot's grabbing arms, followed by the addition of plaster through the nozzle. The processing of materials will be done on the lunar settlement. The lunar regolith will be processed through the method of hydrogen reduction of glass to obtain oxygen and water. The illuminite will be processed with sulfuric acid to form titanium dioxide, which would then be condensed and distilled to finally form titanium, vanadium, and iron. While moving around, the lunar lawnmower will use microwave-based heating to sinter the lunar dust surrounding the area as a dust mitigation measure. This dust will then be used to form smart sintered bricks. The fabrication machine will be used for making the parts of the bots and materials for the settlement. The printer emits metal/composite powder, and an electron beam melting welder will heat the powder slightly above its melting point, applying another layer, and cools down the previous layer so that a material layer is tightly bonded while not getting deformed, and adding some elastosoil to ensure that the layer sticks to one another. Mining will include the mining of titanium for the hull and lunar regolith for radiation protection. The mining will be done by the lunar rover. It will follow the path laid down by the SIIP. The SIIP is a reconnaissance mission which stands for Space Industries Initiative Program, which will map potential mining routes with abundance of certain materials. The lunar rover will use a virus excavator to mine the lunar regolith. After mining, the materials will be refined and products such as oxygen, hydrogen, aluminium, and titanium will be procured. The Near Earth Asteroids mission will begin with the launch of the SIIP to all 15 asteroids. It will be propelled by ion thrusters and a laser cell, which will be used as a solar sail. The second laser sail will be launched into the moon orbit shortly after the launch of the SIIP. Its mission will be to find as many traces of carbon and water on C types, silicon on S types, and nickel and iron on M type asteroids. After it reaches the asteroids through the Hohmann transfer orbit, the SIIP will study the asteroids in great detail. The asteroid mining spacecraft will be launched using SpaceX's Falcon X rocket. The spacecraft will be propelled forward by the laser sails. As it approaches closer to the asteroid, the laser sail attached to the SIIP will start decelerating it. After it approaches the asteroids, the two mining rigs at its sides will descend to the surface and it will start to mine immediately after they reach at the opposite ends of the asteroid. The mining bots will mine the remaining portion of the asteroid. The mining bots will then leave on the storage modules with the mined materials. There are initial equipment and material costs which will be earned back shortly after full operation. There are three revenue streams: tourism, partnering ventures, where we partner with the firms to retail their products on board, and our largest revenue stream is from the sale of mined extraterrestrial resources. Asteroid mining revenue will be $6.4 trillion. When we assume mining of only of 20% of large asteroids, whereas the lunar mining should give us $3 trillion. This is our chart showing our first profit rather quickly for the large scale project it is, and growth doesn't stop there.